Okay, so today's notes, this will be like I said, the first part. We'll only do the first half. We'll pick up the second half tomorrow. Um, so something with these notes and this unit um, about tectonics and plate tectonics is a lot of the concepts and the ideas and all that we're going to see in the next two units that we cover. So get into earthquakes and then volcanoes because those two topics are so closely related to plate tectonics. You're going to see the same things over and over again. So I think it would pay off to really try to get some of these foundations, in and get comfortable with them, because you're going to see the same same concepts pop up when we talk about those other things. So I think the sooner you can get familiar with it and comfortable with it, the better it'll pay off. So and actually on this slide you can see the kind of the background of it. That's actually a map which we'll see again, not today, but later on. It's a map that shows the tectonic plates. And it shows the pieces of the crust of the earth that that move around. So you have the South American plate, African plate, Pacific plate. Up here is the North American plate. Like I said, we'll see this again, but moving on. All right, so this first one, it's just a definition of tectonics. Typically, plate is put in front of it when we use it, but tectonics in general, studying the crust, the mantle, how they interact with each other, how does one impact the other, how does the crust move, how does the mantle make the crust move, all those things. Here we just kind of have a little refresher, if you need it, over the structure of the earth, the internal structure of the earth. So with the crusts, the mantle, liquid outer core, inner core. Hopefully that's still something you remember. All right, this next one has some good terms that we'll use and run into quite a bit. All right, so this first one, the lithosphere. If you remember, it's been quite a while now. Litho means rock or stone, and sphere just kind of means just all of it. So the crust and the upper mantle makes up the lithosphere. That's the rigid, solid part of the earth, the outer part of the earth. It's solid rock. It's hardened. There are two types of lithosphere, or two types of crust. There's oceanic, which primarily is found under the ocean, hence the name. We also have continental crust, which is the continents. It's the vast majority of land on Earth is made up of continental crust. And there's some differences, which we've kind of touched on before when we talk about rocks and igneous rocks. And we'll talk more about it later on, but we don't really need to go into the differences between the two right now too much. I mean, you can take a look at it if you'd like. So lithosphere, that top part, in the diagram, you've got the crust, be it oceanic or continental, and then the upper part of the mantle. Below the lithosphere is something called the asthenosphere. So, the lithosphere, like I said, that's the rigid, hard, portion of the crust that doesn't, it's the rock isn't soft. It's like normal rock like we're used to seeing. It's completely cooled and hardened. Below that, in the asthenosphere, in this diagram, it says plastic-like mantle. The reason it's described that way is because the term plastic just refers to the property of being able to be molded or shaped into whatever. which is why we call plastics plastics, because we can make whatever we want out of them. You make chairs or mechanical pencils or, panels for, cars or bumpers. And you make anything you want out of plastic. It's moldable, it's shapeable. In the asthenosphere, that portion of the mantle, because of the internal heat of the Earth and being heated by the core, that rock is softened. So it's not rigid and solid like the lithosphere is, but it hasn't heated up to the point where it melts and becomes magma. So it's in between, but it is softened. So I had one student in the past that insisted on referring to it as silly putty. So, whether it's silly putty or Play-Doh or something, just remember that in the asthenosphere that it is soft and it does move. It doesn't move quickly, but it does move. It flows over time, but it just moves really slowly because it is very, very thick. It's very viscous. Which leads to the next thing, which is the theory of continental drift. Theory of continental drift, just like what the name says. Continental, so it has to do with the continents, has to do with land. Drifting, so if things are drifting, they're moving. So continental drift, continents moving, or the movement of the continents. Back in 1912, there was a German scientist, Alfred Wegener, and I'm not saying he was the first person to come up with this idea, but he's the one that gets the credit because he was the first one to really publish this idea, offer up supporting evidence for this idea, and kind of the first person to put their neck on the line for this, because up until this point it wasn't really widely accepted. So it was a new idea that wasn't always the most popular with kind of the powers that be. The problem with this was Wegener couldn't explain how the continents were moving. He could give evidence that they had moved, that looking at where they are now, they haven't always been in the places where they are now, and in the future they won't be where they are now. They'll continue moving, but he didn't know how. And remember, this is 1912 when this came out, so he's been working on this for a while. So early 1900s, they obviously did not have the technology or the knowledge that we do now. So that was kind of a big thing that he was missing, was the mechanism of how these continents were moving. And Wegener used three main pieces of evidence to offer up support for his theory of continental drift. The first is just the landmass shape. So just the shape of the continents, which I've also heard this described as the continental puzzle, which, it kind of makes sense. And actually, if we were in school, like every other year, we would actually do an activity where you essentially cut up a map, cut out the continents, and you can move them around, and you can see that they do fit together pretty well, especially the coast of South America and Africa. They fit together incredibly well, especially considering the amount of time that's passed from when they broke apart. So that was his first piece of evidence, was just the shape of the continents. They look like they fit together. The second piece of evidence are fossils. Now, there are other examples all over the world, but this example with South America and Africa is used quite a bit. So what happened was, on the eastern coast of South America and the western coast of Africa, there were fossils that were identical. Exact same organisms, and there were multiples, plants and animals. But these were animals that couldn't make it across the Atlantic Ocean. So if South America and Africa were always, where they are right now, those animals couldn't have gotten across. They couldn't fly, they couldn't swim it. It was too far for them to, have floated over on a log or something randomly. So to, kind of explain this, Wegener was saying that because those two pieces of land had been together, those organisms had lived there, they died there, those fossils formed, and then the land split apart, which would explain, how you could have identical fossils an ocean apart, and then, also have right on the coast like that. That would explain that. And kind of related to the fossils was this third piece of evidence, which is rocks. So he used something called correlation, where anytime something correlates with something else, it kind of matches up with something else. So using rocks and rock layers, you can correlate. You kind of build a picture of all the layers of rock and how they formed. Given that, and given the fossils, the rock layers on the east coast of South America and the west coast of Africa matched up, and the rock type and the rock layers that those fossils were found in were the same on both continents. So those were some huge pieces of evidence that would point to the fact that the continents haven't always been where they are now, that they have moved, and that South America and Africa were together. And like I said, there are other examples, for different continents having been, next to each other in the past, more so than just Africa and South America. But the big thing from this little section, so Wegener came up with the theory of continental drift. Then his three pieces of evidence were the shape of the continents, fossils, and rocks. Those are the big pieces of evidence there. That's all we're going to cover today. Does anyone have any questions or need me to go back to any slides?